Okay then, the line L for part B now of question 8. The line L has this equation here, which we can write down in due course. Find the coordinates of the 2 points of intersection of C and L. So here's C and here's L, so we need to solve that. And then verify that L is in fact normal to C at one of these points. Okay, so let's have a go at this then. Right, so the equation that we have for C, I'll write them down here, is y equals x squared minus 6x plus 7. Label that as 1. And then we've also got y equals a half x minus 2. And that's number 2. So where do these points meet then? Find the coordinates of the 2 points of intersection. We'll let the y equals and we'll have an equation in x. So 1 equals 2 gives, so let them equal one another, the y values that is. So you get x squared minus 6x plus 7 equals a half x minus 2. So leave the x squared where it is. Move the half x over, it becomes minus a half x, so that's minus 13x over 2. Move the 2 over to be plus 2, so 7 plus 2 is 9. That will then equal 0. Double everything. So we'll get 2x squared minus 13x plus 18 equals 0. Let's see if we can factorize it, which we certainly hope we can. That's an x. Now, 2 and 9, that should give 13, shouldn't it? Minus and a minus. That looks good. So here, 2x minus 9 equals 0. Or x minus 2 equals 0. So we can see what the x values are. This one will give x equals 2. And this one, 2x equals 9. And x equals 9 over 2. So there's our x coordinates for the values. Now we can put in, I'll put it here for part 1. And then I'll move up the page. So let me just put it here for now. So at x equals 2, at x equals 2 then, y equals, put 2 in, 2 over 2 is 1, 1 minus 2 is minus 1, and put 9 over 2 in, equals 9 over 2 will be 9 over 4, which is 2 1/4, take away 2 is 1/4. So there we are, so there's our points. So answer for the points of intersection of C and L are the coordinates is 2 and minus 1, and 9 over 2 and 1/4. There we go. So that's part 1 done. Now the next part of the question, it says verify that L is normal to C at one of these. Right, so L has gradient half. So we're asking, when is the gradient minus 2, aren't we? Because that will have a normal. When is the tangent minus 2 of the gradient function? So if we go back up, and we'll just get rid of that stuff here, and then I'll write the answer up here. Okay, let's just get rid of that. So here, so I'm just carrying on with the question now, up here. So dy dx, what have we got then? We've got x squared minus 6x. So dy dx then will equal 2x minus 6, and that equals, now the gradient of the line L is a half, so this needs to equal minus 2, because the product is minus 1. When, so move the minus 6 over, 2x equals 6 minus 2 equals 4, so x equals 2. So the point at 2, we've found the point at 2, so x equals 2 is the value, 2 and minus 1. So the point for this part of the question, of the normal is, and it would be 2 and minus 1, that's the coordinate. Yeah, that's good. So yes, the point of the normal is 2 minus 1. So we verified that there. Okay then, so that's that part of the question done then. That completes question 8. Good.